Okay, so we've seen what one-step equations look like and how we can solve them. We're going to be moving on to our next topic, which is two-step equations. And in two-step equations, usually we're going to have to do, as the name suggests, two different steps to get to our final answer. So once again, we know this is an equation because there is an equal sign in the middle of the terms. And whenever I see an equal sign, I like to draw a line going down, and that represents my magic wall. And that wall serves two purposes. First, it helps me keep all of my equal signs in a straight line. And second, it reminds me that whenever anything goes over the magic wall, the operation changes. So if it was addition, on the other side, it's going to be subtraction. If it was multiplied on one side, on the other side, it's going to be divided, and vice versa. And our goal whenever we're trying to solve an equation is we want the letters to stay on this side, the variables, and in this case it's an x, and we want to move all of the numbers over to this side. Okay, so let's start solving this question. We have 3x minus 4 is equal to 17. And so right away I notice the first thing I want to do is I want to move this negative 4 over to this side over here. Now, while I'm writing everything down, if something is supposed to stay on this side, I'm going to keep it there. So this 3x doesn't go anywhere. We're going to keep it over here, and I'm going to rewrite it, and it's going to be 3x. I want my equal sign to be right on the magic wall, and this 17 belongs on this side because it's a number, so I'm going to write it as 17 over here. When I move this negative 4 over to the other side, it's going to change its operation. And if it was subtraction, over here it's going to become addition. So we're going to have 17 plus 4. Now what we can do is we can add 17 plus 4. So this stays as is. It's going to be a 3x. 17 plus 4 is going to give us 21. Now, we've seen a question like this, 3x is equal to 21, because I did a couple of examples of that in the last lesson. Let's review what that's going to look like. So we have 3 times x is equal to 21. If this is 3 times x and we want the x to be all by itself, the opposite operation of multiplication is division. So what we're going to do is we are going to divide both sides by 3 to get rid of that 3 on the left side and move it over to the right side. 3 divided by 3 will give us 1x. 21 divided by 3 is going to give us a 7. And we don't need to write the 1 next to the x, so I'm going to rewrite that. It's going to be x is equal to 7, and that's our final answer. So you can see why this is called a two-step equation. It's because we had to do our initial step over here where we moved the negative 4 over, and then our second step was this one over here where we had to divide by 3. All right, another example that is similar to the first one that we did. So here we have a negative 5x plus 3 is equal to 18. I am going to begin by drawing a line that goes down my magic wall. Also, it helps me keep everything in order. So once again, we want our x's to stay over here, and we want our numbers to be over here. So negative 5x is going to stay on this side, but this positive 3 is going to move over to this side over here. Okay, so let's erase all this so it's nice and neat. And let's start solving this. Negative 5x is going to remain on this side. So I'm going to write negative 5x is equal to 18 is a number, which means it belongs over here. So we're going to keep that as is. And now I'm going to take the positive 3 and I'm going to move it over here. The opposite operation of adding 3 would be subtracting 3. We're going to solve this. So negative 5x is equal to 18 take away 3 will be 15. So that was the first step of our two-step equation problem. Let's do the next part. So this is negative 5 times x is equal to 15. Negative 5 times x. We want to get rid of this negative 5. The opposite operation to multiplication is division. So to get rid of it, we're not just going to divide by the 5, we're actually going to divide by the negative 5 because we don't want a negative sign hanging around. We want to get rid of every number in front of the x. We want that x to be all by itself. So you're going to divide by this entire term in front of the x, including the negative sign. All right, negative 5 divided by negative 5 is going to be 1x. And now that you've seen this a couple of times, you know you don't need to write the 1. You can just write it as x. 15 divided by negative 15 divided by negative 5 is going to be negative 3. And that will be our final answer. We're moving on to our last example in our two-step equation lesson. And this time we have brackets. We've dealt with brackets before, so it's not something you haven't seen. We learned how to deal with brackets when we were learning about distributive property and things like that, so I want to review that just in case you've forgotten it. So again, equal sign, line goes down. I know this is an equation. Our rule is still the same. We want our x to stay on this side, and we want our numbers to be on that side. Okay, now, as soon as you see a bracket, the very first thing that you want to do is you want to get rid of the bracket because we can't touch any of these numbers inside of the bracket while they're in the bracket. The bracket is sort of like a barrier. It's like a wall and you can't do anything to it. So the way that we are going to deal with this is we are going to distribute the 3 to everything inside of the bracket. Okay, so before we move anything around to either side of the wall, get rid of the bracket. So 3 times x is going to be 3x, and 3 times positive 2 is going to be positive 6. And hopefully you remember that. If you don't, you can try some practice questions or just go back and look at the sheets that you had from the previous unit. So 3 times x is 3x, 3 times positive 2 is 6, and we haven't done anything to the 18, so that's going to stay over here. And now this question actually looks exactly like the other two examples. We need to move the positive 6 over to the other side. So I'm going to keep this 3x over here because that looks not like a 3, so let's try to get that. Because we want to keep the x's on the left-hand side. The 18 stays there as well. I'm going to move this positive 6 over to this side over here. And positive 6, the opposite operation would be to subtract 6. Hopefully by this example you're starting to get the hang of it, so you should be able to see what our next step will be. We're going to subtract 6 from 18, so it's going to be 3x is going to be equal to 12. And now to get rid of the 3, which is multiplied to the x, we're going to divide both sides by 3. 3 divided by 3 is 1x, but we know we don't need to write the 1 down, so it's just going to be x. And then 12 divided by 3 is going to give us a 4.